you can solve anything. I think tech is not that important, but you need to have the right people. If you have people who are curious and have the right attitude and are hungry, then also can work in a team, which is also not given. Then you have everything you need as a CTO to operate such a project.
This whole project was or is a really fun thing. It makes me wake up in the morning and feel like, yeah, I'm really enjoying what I'm doing, and that's something a lot of people don't have when they go to work. They're like, oh, it's just another work day. And I'm waking up and like, I'm super excited to see what's coming next.
Hey everybody, we're live. Today I have to do the intro because Stefan is not here and I'm not prepared to do it. I'm just winging it. Yeah, it's good to be back on the stream. We had a webinar this week already with the same round, where we were 10 minutes late, David, because we needed some extra time for preparation and backgrounds and everything. So yeah, but it's good to be live again. Typically it's just me and a good-looking person, Stefan. But because we don't have Stefan today, we need to mix together 3 other good-looking people. So today here we have Ludwig, Jesse, and Dustin. And maybe we can get a little intro. Hi, Ludwig, and you're working on the what have you been working on for the last couple of months?
Yeah, I've been working a lot with making GraphQL into some kind of reflected gRPC messages. So I've been working on the engine part that would translate GraphQL messages into dynamic protobuf messages and send them over to our gRPC services or plugins regarding on.
It's actually an interesting topic, and we will talk about this a little bit later. In the beginning, we thought, oh, it's gonna be easy. We just connect GraphQL to gRPC, and then we digged a little bit into this topic, and we figured out you can't easily translate everything and the messages, and there are some problems, but we will get to that. Also on the stream today, Jesse. Hi, Jesse. How are you?
Hello, I'm good.
What's your contribution to Cosmo Connect?
I worked a little bit in the very early stages of how we were going to map the gRPC data types to GraphQL ones, and I also worked pretty late in the project on how this integrates with Cosmo Cloud and your very managed system. If you're using,
you're responsible for the bad naming of protographic, right?
Yes, yes, I am.
So, if anybody comes to the Cosmo monorepo and thinks about who came up with this shitty name, it was Jesse. By the way, a funny thing. We also have Dustin here. You changed to co-founder, so you're now also a co-founder, not just CTO. That's great. But a funny story. So Dustin, your intro. How did you come up with the name of Cosmo? Because it's so funny when we created Cosmo, it was more like, so we were on a retreat in Netherlands, and we had to pivot. So that's like a long time ago. I think more than 2 years, 2.5 years, a bit more, or maybe 3 years. I don't know. We're so old now. And 2 weeks after the retreat, Dustin was like, "Hey, I have prepared something. And by the way, it's called Cosmo." And this is so weird that you can talk about this, because at the very beginning, I thought that's a bit stupid. Like, who would call it Cosmo? Like, call it Cosmos or something. But for whatever reason, like Dustin said, it's Cosmo. We kind of settled on Cosmo. And also, funny anecdote: we have one investor. Sometimes they help us. We meet with them and they spell it in a very they always say Cosmos, and we always lose it. It's so weird. But yeah, Dustin, great to have you on the stream. How did you come up with the name of Cosmo?
To be honest, I wouldn't need to make up no story. But it's I don't know. you need to come up with a short name which sounds appealing to people. You need also a free domain, which is very important. What else? I think it also needs to be a little bit inspirational. Like Cosmo is like it's broad. It can't mean anything, but it also does not limit you in your imagination of what it can be. And it's Cosmo is big. It's unlimited, and I think it would be a great term of covering our goals and our ambitions.
Yeah, that makes sense. Well said. It's also, for example, one of the reasons the company is called WunderGraph is I kind of liked the name of graph. I didn't want to have it GraphQL, and I don't know. Somehow I wanted to have something German in it because WunderGraph, it has German roots. Like Dustin and I and Björn, we're from Germany, with a sprinkle of Stefan from Miami. And yeah, it's imagine your company is called something GraphQL, and you kind of realize that you want to enter different markets. Now you have to tell people why is my MCP server from something GraphQL company? And I never wanted to have that kind of situation, so that's why we call it WunderGraph. Can be anything, but somehow it sounds German, and graph is cool. And so, anyways, here we are. We launched Cosmo Connect this week. We had a webinar. It was pretty good. It was, I think, the best webinar we ever did. And it was the first one. And yeah, maybe we can talk a little bit about what is Cosmo Connect and why we built it, and what were the challenges, and what's actually behind the scenes, like how does it even work. And then Cosmo Connect is actually multiple things. You can speak, instead of speaking to a GraphQL subgraph, you can speak to a gRPC subgraph. It can be a dedicated service, or it could be a plugin. And maybe we also want to talk about what is a plugin, what distinguishes the two, when would you use a plugin, and how does the plugin even work, because the code needs to somehow get to the router. And I think that's a pretty interesting story, because Jesse, having worked at Fly before, he figured out a pretty cool, like a pretty cool way of putting together the stuff for a plugin into an OCI thing, and then pushing the OCI thing into. So I don't know. You need to tell us. Okay, where do we start? What is Cosmo Connect, and why did we build it? Please don't everybody speak at the same time. Do I need to point fingers, or who likes the question?
No, I like it. I mean, our initiative, our goal. I mean, we love many great customers, and what we have seen as a pattern is people understand the benefits of a supergraph. However, not every team can adopt it, because it's a learning curve to adopt GraphQL, doing GraphQL right. It requires different technology. You need to adopt to a subgraph framework, which also has its quirks. And the biggest factor is you probably already have established an ecosystem and a service that you don't want to change, because it's working fine in production. So how can we bring those people into the supergraph so they can benefit from all these things, like analytics, break and change detection, schema collaboration? And then I think we also got great feedback from a customer, and I think one of the solutions was to remove GraphQL from the backend side, because people believe and also understand the benefit of on the consumer side, on the front end side. And then it was I would say, a very natural fit to say, why not using gRPC? Because gRPC is so established in the industry. It's known for its performance, type safety, and also easy compatibility with the ecosystem and programming languages. And then we thought about, like, why not creating something that can translate GraphQL to gRPC? Then we could leverage from all the benefits of the gRPC itself, and so that people can purely focus on business logic, on implementation, and bring in that way existing REST API or SOAP API into the supergraph.
Yeah, and if I remember correctly, in the beginning we were talking a little bit about what are the possible technologies, and well, one thing I keep seeing is people keep coming up with use cases where they think WebAssembly would be amazing, and we also had like in the very beginning we were talking about like different approaches, like how could you actually do it. One idea was also WebAssembly. But we didn't go for WebAssembly. Like, what's, and I ask everybody in the like, what's your take on, like, will WebAssembly ever be like the standard in extending something like a router, or like why did we go for gRPC, and how in general how you think about like the extending like a binary with custom customer stuff?
I can talk about this a little bit. I think that WebAssembly is great, and using things like shared objects and DLLs is great, like the new Go plugin system that's like officially in part of the toolchain. However, one of the main goals of Cosmo Connect was to take the onus of the complexity of importing GraphQL frameworks and all this subgraph nonsense and just make it easy to do what you've always been doing, which is import protobuf, proto-C, proto-C-gen, gRPC Go, all these packages that everyone's used to, and be able to federate those into the supergraph. And if we bring all the complexity of developing WebAssembly programs into that to replace it, I don't think we've made much of a stride at all. There's issues with concurrency and language support and all kinds of little gotchas with WebAssembly right now, especially if you're not using a web browser as your runtime. So,
and you would also need to build your own SDK, right?
Yeah, you absolutely would, because there's pretty much nothing available in WebAssembly. There's no standard library. So you would have to provide all your own bindings to the WebAssembly engine. Just a whole lot of extra new, like it's all greenfield for anyone developing these things. And as opposed to gRPC, they have to learn this whole new technology and how to work with it. In some languages, it's even outright broken. So
whenever someone comes up with like WebAssembly, like being a Go dev, like I think we all tried WebAssembly probably, and if you try out using WebAssembly and you're using a garbage collected language and you know a little bit about architecture of programming language and stuff like that, the first thing you kind of stumble into is, okay, if I want to get some information into a WebAssembly thing and then call a function and get some other stuff outside of the WebAssembly thing, what I have to do is, because WebAssembly, the way it works, it doesn't give you like garbage collection or something. You have to allocate space, somehow get something in, like copy it into the thing, into the runtime, and then do something and copy some results into some other space and then get it out. And I was always like, I don't know. One thing I really like about Go is, and then you can have opinions on Rust and non-garbage collected languages, but what I really like about garbage collected languages is I create an object and I do something with it, and when it goes out of scope, then that's fine, and I don't have to think about memory management and stuff, because lots of other problems to solve. With WebAssembly, you have to think about this somehow, because you can't just randomly allocate stuff and not care about things. So, and I had discussions with Dustin. Initially, I wanted to go for WebAssembly, and he quickly came up with alternative ideas. Maybe you want to share some of your thoughts and how we ended up using what we're now using, which is a pretty cool library from HashiCorp, I think.
Yeah, I think Jesse summarized it pretty well. Why choosing WebAssembly wouldn't have been a good idea in that case. Then we explored, like, for instance, like Go also has a capability to produce plugins, but those plugins only work, I think, on Linux, right? And those are like compiled, I think, libraries.
Go plugins are horrible. Like,
yeah.
one of the biggest problems is you must use the exact same package versions of every dependency in the main binary and the plugin, and that's not fun.
Yeah. So first of all, we talked about WebAssembly, and then we. I mean, the whole initiative was driven by the idea that people doesn't need to recompile the router. That was one of the design goals. So then WebAssembly we figured out. Then for obvious reason we didn't do this. Then we thought about like an co-processing model where the router can spawn processes. Then we checked, I think Go plugins, which is obviously not a good choice. But then if you research a little bit about Go plugins, you will always find a HashiCorp library as the first search result. And because of it's already so wide adopted, also in HashiCorp Vault, in HashiCorp, and all. I mean, a lot of many HashiCorp products which are serving millions of users per day. For us, it was a good signal, like it's production grade, and it would give us all of these benefits we are looking for. For instance, like one of the goals of the plugin architecture is also that we want to bring that aha effect, this exact aha effect immediately to a customer, so they can build things without redeploying services. Everything should be self-contained in the router. On the other hand, we also didn't want to destroy the capability of deploying these services independently for high traffic scenarios. So I think that was the perfect match, because at the end it's just a gRPC service. And in case of a plugin, it has a different transport, and in case of gRPC services, it's really handled as a separate subgraph. So yeah, and then that was I would say the decision matrix in that at that time.
Okay. Well said. So Cosmo Connect. I have a supergraph and I have a router. And in this supergraph, I have one subgraph. I have defined it as I have a schema, like Apollo Federation subgraph spec compliant subgraph schema. So that's one thing I have. And then I have my router, and I have my gRPC proto thing. So now if I send a request to the router, and we get some data from a GraphQL subgraph, and we get some data from a gRPC subgraph, what happens? Can I, like, how do you translate between GraphQL and gRPC? Because if I'm like a regular gRPC user, the way I'm used to doing gRPC is I have this proto stuff, I run some proto-C thing, and it generates code, and then I have a the gRPC server. But in the case of the router, what Dustin just said is we're not recompiling. We're not, like, when you change your subgraph, you don't have to rebuild the router with new proto definitions. Somehow we're building these messages on the fly. How does it work?
So basically, you start off with designing your GraphQL schema just the way it's always been before. You think of a schema that matches your architecture or fits into your existing architecture, and then after you're done with your GraphQL schema, you can use our fancy library Protographic in combination with our CLI WGC. And you just you use the schema as an input, and you generate protobuf out of it. So you get a protobuf schema, and you also get a mapping file. So basically, because GraphQL and protobuf are quite fundamentally different, there's also like different syntaxes, different ways of handling types. We use our protographic library to find the best way to match between the two environments. So we're generating a proto schema from the GraphQL schema, and the user can then take the schema and just generate their proto bindings from it. On the other hand, when we're composing, all our graphs into a router execution config, we're putting together all the information that are required. So we're getting the GraphQL schema, which is important for our engine to understand what types are there are available in my GraphQL sense, because I'm still talking GraphQL to my router while I'm talking gRPC to my service. So on my router level, I still need to understand GraphQL, but we only need the schema for that. But on the gRPC level, we just need the protobuf schema, and we can compile this protobuf schema using a library and convert it into an AST, and then use all the information that we can get from it, like the type descriptors and whatever, and build up dynamic proto messages. So while we're getting GraphQL requests, we can just take this request and convert it into protobuf messages dynamically, and then send them over to our subgraphs, our gRPC subgraphs. And using a mapping file will allow us to retain the information that we get from the original GraphQL schema to the protobuf schema to get a mapping between the type and the names.
Okay, so you have a mapping, you have the message descriptors, and there's like a dynamic library. It allows you to create those messages on the fly. So you take subgraph requests, you transform them into gRPC proto messages, send them, get them back, and all without the compile time step. What were there any challenges? Is it easy? Is there something that you learned in doing this?
Ludwig mentioned Ludwig mentioned the mapping file, and one thing. I mean, the obvious reason why we choose this approach and why we started thinking about this, like in Proto, the field order is significant. It's a binary protocol, so you cannot just move fields around. Otherwise, it's no longer binary compatible. In GraphQL, you can move arguments, you can change fields order. It doesn't matter. That means we have to retain this information through the conversion process, and then we store it into the mapping file. And
you're mixing up two things right now. We have the mapping file and we have the log file. The log file is for the field order, and the mapping file is just for the naming.
Okay.
Oh, Dustin.
Good that you mentioned it. Okay.
We can talk about the log file later.
Okay.
Cosmo is such a big space. Yeah, there's a lot of moving parts. Yeah, but we talk about the log file later, because I learned something from Dustin in this doing this. I didn't know there's a cool keyword in gRPC. It's called reserved. I didn't know about reserved, and Dustin pointed me towards it. It's pretty cool. But we talk about this later. Ludwig, anything in your process of like taking subgraph requests that are like GraphQL over JSON over HTTP, turning that into gRPC? Anything that was hard, or something you learned, or anything you want to share?
I would say the whole project was a big learning process for me, because when I started with this project, my knowledge in our engine repository was quite limited. I've been mostly working on Cosmo router features, and the engine part was always like this very complex planning part no one understands. And when I started working it, I got a lot of support from, especially from Sergey, who showed me a lot of things, how to use the libraries, different packages that allow me to traverse, for instance, GraphQL requests, or schemas, and what kind of metadata we already have available. So I would say the first challenge for me was getting into understanding how the engine works internally. So I started writing a visitor the way that we're doing it usually in our engine code is we're writing a lot of visitors that do validation, post-processing, and so on. And I started with a simple visitor that would take a simple request, a simple GraphQL request like query user or query users with one field without arguments, and just convert it into a very, very simple gRPC request. And after I was done with that, and after I had my initial aha moment, my wow moment, okay, it works. So I started digging deeper. I started with, okay, let's start with different data types. We're supporting different data types, and we need to support like scalar data types in GraphQL. We need to support like the base scale, the base types in protobuf, and they also sometimes translate differently. For instance, in GraphQL, we don't have a 64-bit integer, so we only have 32 bits. But instead, the float in GraphQL is actually a double precision float in protobuf, so we would translate float to double. So I started digging deeper and deeper, and I just built on top of it. And I always had in mind that I want to build something that kind of keeps its simplicity while still having like a good way of using it, like provides a good developer experience. I wanted to keep it super simple, not making it super complex with nested messages and like very nested complex types. So I wanted to keep it as close as possible to the original design of the GraphQL schema. So yeah, so it was a gradual process from starting super low with basic types, and then going over to arguments, then thinking about federation directives, like how can I build my first entity lookup, and then at some point we reached a point where we started working with lists, and I was like, oh my god, this is very tricky, because in protobuf, for instance, you can't have lists of lists. The repeat is only available for a single type, so you can't do repeated type. So we had to come up with a way of translating nested lists into something that that protobuf can understand. And also on the engine side, we need to handle different ways of handling lists, because you can have a nullable list, you can have a non-nullable list, you can have a nullable of non-nullable list, and it was kind of interesting. So we had to do a lot of. I had to do a lot of logic bouncing between the two designs. And
are you following the semantic non-null discussion in the GraphQL community?
There's an ongoing discussion.
Yeah, like one of the biggest problems we currently have in the GraphQL space is if we request a field and it's nullable, do we get back null? Do we get back nothing? Or an error with null? And does null mean nothing or null? Or like, does null have a meaning, or is it an error and null? Or we don't always know. For example, let's say you make a subgraph request and it should return a nullable field, like I don't know, best friend. And let's say you don't have a best friend because nobody likes you, so your best friend is null. But it's also possible that so in that case the server the subgraph returns null. But what if the server has an error and returns null? How do you distinguish? And so the stupid thing is we don't have a way in JSON, like, you know, sometimes I feel like JSON should have like undefined, like, you know, something is, and I kind of like this in JavaScript. In JavaScript, you can say something has a value, it's undefined, or it's null, because then you can express that we don't have something with null, like the value is actually null, and with undefined we can say there is nothing. But that's a different topic. I also want to talk about the log file with Dustin, and later on I want to dive a little bit into the topic of OCI. Like Jesse does some really cool stuff with OCI. Just one quick question, Ludwig, because this is something I stumbled into a while ago. Are you supporting big int? Because a while ago I realized a big int, you cannot represent it in JSON like a number. It's actually in JSON, it's a string. Have you ever thought about big int in the context of your project?
In the context of my project, so we only have ints currently, which are 32-bit integers in protobuf. And the idea of how to handle like bigger ints would be to use a float instead. So you can use a float to have a 64-bit integer if you wanted to. You still have like a floating point number, but if you're just providing an int, you just get an integer without a floating point if you pass it properly. So that is, okay. I think that is the idea in GraphQL. At least when I read through different posts, people would always recommend to use a float instead of an integer.
Yeah. But by the way, just remember, like we have David here. So if you want to trigger David, someone can just say something wrong about federation or composition, and just for fun. Because he wasn't active on the chat for a while. But okay, Dustin, very early on, I think it was you who came up with this idea, or we were testing and we were trying out things, and I kind of vaguely remember I was your rubber duck. We were playing around with Cosmo Connect in the early days, and we realized like shit, we have a problem. Like it's not gonna work. Like we quickly found a solution, but there was a severe problem because you can do things in GraphQL schemas that you definitely shouldn't be doing in gRPC, right?
Yeah.
So what did we learn?
This is live, right? Otherwise, I would say cut my previous sentence and put it into this moment. No. Yeah. I have to repeat myself. Like in GraphQL, the order of fields arguments is not significant. So you can play around. It doesn't matter for semantic. You can get the same result back. However, in Proto, the field order is significant. That means if you change a field order in GraphQL, we also need to be backward. We need to produce the same proto structure in proto. So, and in order to retain this information, you need some sort of, you need to store that information somewhere. And honestly, I don't remember anymore what other solution we approached, but this was, I would say, I mean, if you know of npm log files and stuff, that was one of that come up in my mind immediately. And we followed this approach, and so if you compile something from Proto to something from GraphQL to Proto, it will not just create this mapping file JSON, but Ludwig mentioned, which contains the type mapping, but also you also produce a service Proto log JSON file, which has the information of the field order. And when you change a field in a GraphQL schema. We will also use that you mentioned the reserved directive to continuously make the proto message compatible with your previous changes if it's not a break-in change.
So let's say I create a user type and it has ID and name. So then ID in the proto definition, it would be like index 1. And name is index 2.
Yeah.
So let's say I now remove. Okay, that will be a breaking change on the GraphQL side, but let's just say we do that. So we remove the name field. You would then put the index 2 in the proto as a reserved index,
and it would count one level and assign 3 to the new field.
If we add a new field. So if we then add, like, I don't know, foobar, it would automatically get the index 3, so that we're not mixing up index 2 and 3.
Yeah. And the reserved also supports ranges, so the protographic library automatically identify if we are in a, like we made multiple changes over time, so it for efficiency reason it instead of having multiple reserved statements, it would just use reserve from 2 to 4, for instance. Yeah.
Okay. Cool. So we have our query. It goes to the router. The router does magic query planning. By the way, query planning, it's a topic. On day one, God, Sergey, and I understood the query planner. Now it's just God. No, for real. The funny thing about our query planner is every time I have to onboard someone, like I wrote parts of it, and I'm more guilty of contributing to the execution. But every time I have to onboard someone to our GraphQL Go tools, it's like a little birthday party for me, because where I feel like a squirrel, you know. I look into the code base and I find things, I'm like, oh, interesting, this is how we did it. And yeah, like the code base is just so insanely big, it doesn't fit into your head. It also doesn't fit into an LLM. And LLMs, that's a topic I want to pick up later, because Dustin did some amazing stuff with integrating cursor workflows into this whole plugin architecture. But first, we need to talk a little bit about, because we have plugins and we have like dedicated gRPC services. So that's one thing. And maybe we can distinguish, like, what when we talk about Cosmo Connect, like what do we mean by a plugin and a dedicated service? How do we distinguish the two? And then we want to talk a bit with Jesse about, like, what are we doing with the plugins, and how do we handle it? So who explains to us the distinction between plugin and dedicated gRPC service?
Sure, I can take this one. When you're developing your gRPC Connect plugin, you have two options for how you want to build it and deploy it. So the first option, which is kind of like almost serverless, like functions as a service, is to use our compatibility library for router plugin, and you can build it using our CLI and ship it off through Cosmo Cloud or on the file system. And the router runs it as a subprocess, sort of like it's acting as a supervisor. And that means that it's running right next to your router, and it's communicating over a socket, not over the network. So it's very low latency. What you lose
kind of
here,
socket?
Well, it depends on the operating system, but like a pipe.
Okay, so like Unix domain or whatever.
Yeah, it would be Unix on a Unix system, or like a FIFO pipe on Windows.
Okay.
And that's a great option if what you're looking for is just a lean way to deploy something thin, and you aren't too concerned about like resource consumption or really in-depth monitoring or doing other very process level control over your plugin. And it's not really going to have any downsides in the long term if you're not needing any of those things, because the only real challenge that you'd run into is either your platform team doesn't want you running processes inside your container that are getting forked from a source control they don't trust. That's one reason you might want to go with the other option, which I'll get to. Or you want to allocate resources like per pod or per deployment specifically for your plugin. So if your platform team gets mad at you, the other option is to develop it as a completely separate gRPC service, same as you would for any other microservice architecture, which can be deployed any way you would deploy any other thing on your infrastructure. It can go on Fly, it can go on Lambda, it can go on Kubernetes.
Please not on Fly.
It might go down once in a while. And you can use your own Prometheus metrics, OpenTelemetry, you can do BGP, whatever you want, because it is a completely separate process run underneath your DNS, your service mesh, whatever you'd like. And the router just contacts it via however you would normally want to network your services together. And that gives you total control over the deployment, the versioning, the packaging, and that's really going to be best either if you have something complex that needs its own resources or access to, what are they called on AWS, like a virtual private network or something like that. AWS is a fancy word for it. Like if you need access to RDS or something, That could be a good option. But you
Okay.
get all this control.
Yeah, got it. So we have like the lightweight option, the plugin. I think that's a pretty good option if the plugin just talks to another API.
Yeah.
Like it will just be I/O. It cannot use a lot of CPU and memory, so it's fine. Just run it as a plugin. That would also be like our I would say alternative to Apollo connectors. Yeah, connect. It's always a problem. Is it Cosmo connectors or Cosmo Connect, and is it Apollo connectors? Or I sometimes stumble. Okay, so we have plugins, lightweight, just I/O, talk to something. If you do some more heavyweight stuff, then dedicated gRPC. Okay, we got that. And okay,
maybe
so
maybe just another 2 points. I see also very huge benefit in like local development if you just want to try something out, but also for preview subgraph changes. So you can also create, like in Cosmo, we have also the concept of feature flags. You could also deploy a Cosmo Connect plugin and deploy that as a feature flag, and that means you don't have to deploy another router to preview your changes on a QA system.
Okay, that's
if
an
you're
interesting one.
if you're working on a plugin, you can just add another main file and convert your plugin into a service, like reuse the exact same code that you have been using for your plugin. Just have another main file that starts the plugin as a gRPC service and just deploy it somewhere. So you have a plugin and a service.
Yeah, that's really important. When we talk about these two separate ways of deploying it, the only real difference is just how the service is initialized. All of the resolvers and the whole like gRPC innards are identical for both implementation methods. It's just whether you use our helper to run it on the socket using HashiCorp Scope plugin, or whether you launch a bog standard HTTP2 gRPC server over the network.
Yeah, but there's one thing that Dustin mentioned. That's an interesting point. We have never made it like a very big thing, but imagine we have a staging environment and we have a new use case. We want to build a new feature. We currently don't have a lot of resources to implement it. What we could actually do is we create a feature flag. So Cosmo has a thing called graph feature flags. It creates a copy of your graph and you can replace subgraphs in it. So what we could actually do is we create a feature flag, and under the feature flag, we just create a plugin that adds our functionality. We say, hey, cursor, implement me this plugin with some mock data, whatever. And instead of deploying a service, which could be like a heavyweight operation, we need ops and whatever. Let's say ops is not here. We could just say, oh, to this feature flag, just deploy a plugin with some mock data, and that's it. And now we have something running in staging. So that's I really like that. And then to your other point, Dustin, because this is one of my main criticisms of Apollo connectors. You know, Apollo connectors, you have a subgraph schema, you put some weird directives on it, like at rest, whatever, and you kind of map your GraphQL to REST or HTTP. And the typical approach to debug problems is, and this, by the way, you like, sometimes Apollo goes like, oh, it's declarative, this is so amazing, and I'm like, no, declarative is really not amazing, because the biggest problem with declarative is you have this spec that you give the router, and now you send a request and you open the playground and you look into the playground what the router does. And if the router is not doing what you hope it should be doing, what you gonna do? Like, how will anybody tell you what's in your mess of directives you have created is wrong? I don't know. I think it's very hard to debug. Versus, Dustin, how do I debug a plugin?
Yeah, it's just a service. I mean, it's just a process, and you can, depending on in what programming language you have implemented the plugin, you can just open your Golang IDE, your VS Code IDE, and attach to that process. And because there's nothing special in it, you can make a query from the playground. When it will hit the plugin service, you will, debug as usual.
So a plugin, like we don't distinguish between subgraph and gRPC. Like it's just the gRPC methods. You use VS Code and Delph. You connect to the process and you look what's going on, and that's pretty easy and to do. And also other things. If we're already talking about like comparison, for example, with Apollo connectors, a lot of let's say we want to integrate an external API, Stripe, whatever, some API from AWS. They all have SDKs, and SDKs, good SDKs, they do more than just calling a REST API. They can help you with authentication, signatures, whatever. Like if you want to talk to things in AWS, you have to sign requests, and there's like different requirements. You like if we're talking about like real production grade stuff, you have to stick a lot more things into Connect directives than just talking to a REST API. In reality, like in AWS SDK, it does a lot of things for you, and it can be very helpful. So with Cosmo Connect, you can just import those SDKs and do whatever you need.
I also think there's an architectural break. Do you really want to give your schema designers that responsibility of integrating APIs? I think, I think no.
No, not even that. But my personal pet peeve is when you design a schema, like for example, you create an open API spec. Ideally, you really just define the spec or the GraphQL schema. You just say, here is the schema. I make this an entity. And that was always my idea of APIs is the spec of the API should define the contract and hide from me the implementation. Like I don't want to leak the implementation into the contract. So and this is one of my worries with Apollo connectors. If you combine schema and directives to connect to REST APIs into one thing, it is possible that you design the GraphQL schema after your REST API, because you have this natural tendency of, I mean, you have them both on the same page. So why not use the GraphQL and follow more the REST? Because that's what you connect, and then you have to do mappings and things. And so this is one thing. And another problem I have with these directives is, I think they are very verbose. And if you look at the schema, it is not super clear what is the schema. So you have schema and you have connectors, and it's a mix. And I think it's much easier if we just have our entity schema and whatnot.
I mean, this is a great discussion, I think, for a separate good thing. But also, like, I also want to highlight, like, how do you do error handling, right? Like, it's another beast.
Yeah, you know, like you're triggering me, but I wrote blog posts on all of this. But this is also from one of my blog posts. When you integrate with a well-designed REST API with a good open API spec, a good REST API, sometimes they return unions. So there's like the one-off directive or any off, and then they can have discriminator fields or maybe a header to discriminate. And then you can also have status codes as discriminator. So that means you have like 3 possible options that distinguish what is actually coming back. And then now here's my question. Let's say you have a REST API and it returns 5 possible things. Do you really want to create like a union in your GraphQL schema that can represent the 5 possible things and then map them? Or do you just want to say, oh, in my GraphQL schema, I don't care about all these errors. They mean nothing to my front end. I hide them completely away. Let's just focus on our use case here. And if something goes wrong, we just say it goes wrong, like it's broken. Like, do I need to expose a rate limiting error from Stripe to my front end, where the front end guy will? What do I do with the Stripe rate limiting error? Like, it doesn't matter for this here. Jesse, you feel you need to say something?
Yeah, if we take all this kind of negativity about how you could use a DSL in your schema to describe an external API, and you kind of just completely flip it to how we approached it, we have a full programming language to handle all of these transformations and different error paths you might want to handle. You can do anything you'd like with the response from the API you're wrapping, whether it's iterative transformations or completely changing the shape. You can even join different things together. Like, let's say you have a REST API that has posts and authors, and GraphQL expects those two things to be in the same type. You can just merge them. It's not mental gymnastics to figure out how to represent your business use case in some limited language. It's just programming.
And if someone would argue that, hey, I can just do it in my schema and I don't have to do anything. I mean, with plugins, you can also just build your plugin and deploy it with the router.
Yeah.
Which is a good segue. Plugins, router. So I have my plugin. It's probably like a Go binary. How do I get it to the router?
Well, if you're not using Cosmo Cloud, like if you're self-hosting, you can directly include the plugin's code in the file system next to the router. You can do this via a PVC in Kubernetes, or you can include it directly in the image. You can use Ceph, whatever. It's just put it there in the file system. However, if you are using our cloud product, you're able to use the publish and pull workflow that's built into WGC, which uses Docker to package up your plugin into, or uses the Docker builder to package your plugin up into an OCI image and ship it off to our registry, which can then be pulled down by the router alongside your updated execution config that includes the new version of the plugin and its schema. And the router can automatically unpack that image into a working directory and run it as it would a local plugin.
So you're abusing OCI storage to upload plugins and download them.
I wouldn't say I'm abusing it. I would say that we're one of the pioneers in the new space of using OCI stores as generic artifact stores. There's other projects in this space, like Helm uses OCI specifically not to contain container images. And there's a couple new projects that are being started up, like generic image registries that don't have any of the Docker MIME types in them, which are a real detriment to this process, is having your MIME type stuck as like tar.docker.image or some other nonsense like that. Because the OCI spec as it exists right now is really derivative of the Docker image spec. But the whole underneath them, what's it called? Cloud Computing Foundation with Linux Foundation, they're really trying to move it away from that and into just a real nice content addressable. It has SHA checking, all kinds of other nice features that you would want out of an artifact store.
I also have a question to Jesse. I think, or maybe you wanted to ask. I'm not sure, but we didn't build or deploy or maintain our own Docker registry, right?
We did. It's it's based on Cloudflare workers, and it uses R2 as the backing storage. This allows us to deploy it in all the regions where our customers are and provide fast service without depending on an external service like Docker Hub or GHCR. In the future, we might have some sort of option for using your own registry, but that's on the horizon now.
I think I feel much better if we don't have our own storage. Like let people from Cloudflare store the stuff. They can figure this out.
I meant using like gRPC if you're a self-hosted customer.
Yeah, I see. Okay. One last topic for Dustin, Cursor, and then to close it up. I will do one round of what are you proud of? Like something you have built the last couple of months. Can be Cosmo Connect related, can be anything, like something you're really proud of, where you say, okay, this is I built something cool. Before we come to that, which will conclude our end of this session today. We started a bit late, and we just drag it a little bit. But one last topic, Dustin, cursor. We're all lazy. Developers are lazy. Nobody wants to write code that, someone said at some point, a human shouldn't do what a machine could do. And writing glue code to connect to a REST API, that's maybe a case where AI could do some stuff. But one of my early experiments showed it's actually not so easy to connect or to implement an Apollo Federation subgraph with LLMs or Cursor or Claude Code. And you have invested a little bit into Cosmo Connect, and it actually works with LLMs, or like how does it look like?
So right now, when we in the first iteration of Cosmo Connect, we relied heavily on convention. Like we have different directories where we put the binary, where you have to put the GraphQL schema file in it, where we store the generated files from the GraphQL to proto conversion. And this structure allowed us to define like a cursor or windsurf or a Claude template that is able to instruct how to actually operate a plugin. That means how to build it, how to generate it, how to test it. And if you're doing some clever prompt engineering inside, it is possible to instruct Claude, for instance, or Cursor to implement an OpenAPI specification. And this workflow works pretty well. And in this way, you can actually integrate or bridge REST APIs very easily in almost no time. However, this always comes with limitations. So we also need to be able to solve use cases like where you have an OpenAPI spec with thousands of endpoints, right? And this will obviously overwhelm the LLM to do things right. And for this purposes, we also have a different product in the pipeline that allows you to split those gRPC endpoints in several, I would say, pieces, so that multiple agents can run on these things in parallel. And it's not yet part of Cosmo Connect, but we are aware of that limitation I would describe, that you usually need to solve on your own. And yeah, exciting stuff. And we will also, I hope, also have a good thing about that as well.
So we're looking into bringing API integration on, getting that on autopilot.
Exactly, so that someone can easily bridge an existing REST API within a day, including tests, everything.
I think one of the understated benefits of using gRPC for having your AI assistant write things is that it's very easy to tell when a gRPC API is behaving within spec. It's not so easy with a GraphQL API. If you developed your own GraphQL server from scratch and you wanted to make sure it was working correctly, you have to kind of try everything. This underneath this, like A, B, C, all these like nested queries you do, things that return arrays, or all these different ways of querying the same data in order to make sure that it's doing the right thing. With gRPC, there are RPCs, and they have an input type and a return type. And if they act within that spec in one test, they will do it in any circumstance,
and
more or less.
And when we convert like GraphQL to protobuf, we also retain the GraphQL descriptions. That means this will also serve as additional context to LLMs to understand the full context of your domain.
Okay, awesome stuff. Then
good that Ludwig is back.
then we will do one round of something you're proud of, and then if you think that's funny, in the end, you can ask me, because I was just moderating all the time. You can ask me like one weird question. If you have a weird question for me, think about it. But starting with Ludwig, anything you're proud of, except like your amazing teammates and what we have accomplished, and
That was actually the thing
you're
that I
probably
wanted to
proud
say.
of the best CEO, right?
Of course, the very best CEO.
Yeah.
Do I get a raise now? No, I actually wanted to say I was super proud of the whole collaboration. Like in the beginning, we had a super tight schedule when we wanted to have our first version released, and I could not have done that alone. And I got massive support from Dustin, from Jesse, from other people also involved who helped me with some designing things. And really, I think this whole project was or is a really fun thing. It makes me wake up in the morning and feel like, yeah, I'm really enjoying what I'm doing. And that's something a lot of people don't have when they go to work. They're like, oh, it's just another work day. And I'm waking up and like, I'm super excited to see what's coming next.
Which is a great point. Like if you like people like Ludwig, Jesse, and Dustin, and like, yeah, you and if you can cope with me, then maybe WunderGraph is a cool place, because I think we have really cool, smart people. It's very enjoyable, and to work together. We have super interesting problems, like what we just talked about. Like I would love to have more time on actually hacking on it, but yeah, I also need to do other things. Cool. Thank you, Ludwig. That was fun. And Jesse, anything you're proud of, or something cool you worked on?
So one thing that I'm proud of for the team who worked on Connect is that I have an Excalibur diagram on my other screen here from 5 months ago. This was before any code was written for anything here. And this was Ludwig and I sitting in a Slack huddle trying to figure out how this is going to work. And if we look at this diagram now and how it actually ended up working, there's like nothing different. So I think we did actually a really good job of architecting it from day one, so that we weren't just stepping on our own feet or constantly messing up how we were going to implement this. We weren't like vibe coding our way through it and constantly having to rewrite things. I think we did a good job planning and executing a product that functionally works in production and solves the use case it was designed to.
Respect. Like the in German, the biggest level of appreciation you can get, it's not bad. Like really good. Okay, cool. So you see, we have good collaboration. We have good architects. Dustin, what are your highlights of the last couple of months?
Yeah, I have to repeat. I think. I mean, I think you can solve anything. I think tech is not that important, but you need to have the right people, and I think this is the most critical one. If you have people who are curious and have the right attitude and are hungry, and then also can work in a team, which is also not given, then you have everything you need as a CTO to operate such a project. And yeah, I tried very hard to be part of it. I did some work on the photographic library, but I was more or less like a rubber duck and an architect on that side. And yeah, the team did a fantastic job.
This is what you want to hear from a CTO who cares about the team and the people. Cool, awesome. This was a cool session. Has anybody come up with a weird question?
Why did we use gRPC and not Captain Proto?
Oh, this is actually not a super weird question. So if you don't know Captain Proto, I'm actually a fan of Captain Proto. If you should definitely read about Captain Proto, because, and by the way, this was not like Jesse and I didn't set this up. Like this is free for all. So a backstory of Captain Proto. So what did I want to say? Cloudflare. Cloudflare Workers is using Captain Proto behind the scenes. They have something, it's called, what was it again? The distributed object, like what's it called? Something.
D1.
D1. D1. Okay. Yeah, they have this cool concept of distributed objects, which are like singletons, and they can move around the globe. And essentially they are Captain Proto objects. And the cool thing, like Captain Proto is like a different way of thinking about network programs, because instead of calling a service and it gives you something back, it's more like you have a distributed object that lives somewhere, and you can call functions on it, and you can also chain function calls. You can say, I don't know, show me the prices of products, and when you have the prices, then give me, I don't know, the shipping estimator or something. And you can actually send this in one message as a chain, and it will operate on this distributed object one by one, and then it will give you back the response. So you can send multiple operations to this object as one request, and then you get back the response. You don't have to go like multiple round trips. So Captain Proto, pretty cool. Why did we not use it? I actually wanted to use it in the beginning, but I was worried about ecosystem. So I thought, like, if we do like an exotic ecosystem thing, then yeah, maybe we end up with, I don't know, like not many people will adopt it. So I thought, okay, let's go mainstream. Let's go gRPC, and that's fine. Good. Then last question from David Studd. Why did you come into daily yesterday with a huge cake that you finished by the end of the daily? I don't know. Like, if you have cake, you want to eat it, right? So why did I come? I came into the daily because my mother-in-law, she's the absolute best. She made cake, and I like cake, so I had my cake and ate it too. Exactly.
I think that's like awesome closing words.
Yes. Okay. So next week, our beloved Stefan is back again. But I have to say, this was an awesome session. We had very good, I don't know if you see it, but we had very good numbers in viewers, and people stayed. So it was interesting. That's a good learning. Jacob, I hope you can clip some stuff. Hopefully we had some good rants or whatever. Guys, Ludwig, Jesse, Dustin, thank you so much. This was a good session. And Dustin, or how do I do it again? One sec. Dustin, do you know what the good thing is? Jesse, do you know what the good thing is?
A podcast?
That we are online next week.
Thank you. Ciao, guys. That's it.
See you.
Bye.